So we want to implement the cost function and the gradient for logistic regression. And the cost function looks like this. And just quickly, how we can interpret this cost function is that if the y label is 1 for this particular training example I, and the hypothesis is close to 0, so our prediction h is wrong in this case, then we take the minus a log of approximately 0, which is a very, very large number. Similarly, if we have that the y label is 0, but our prediction is close to 1, then we get minus 1 times log of about approximately 0. So here again we get a very large loss. And the idea here is that we sum for all training examples, and then we take an average by dividing by the amount of training examples that we have, which is m. So what we need to do first is that we need to have an hypothesis, right? We need to have the h. So the h in this case will be the sigmoid, but we need to know how we should multiply x and theta. So if we run, let's see, if we run this, then we get that it's a, let's see, x is 100 by 3, 108 training examples, theta is 3 by 1. So what we want to do here is that we want a prediction for all training examples, so the result should be 100 by 1. So we can call h, which is sigmoid of x times theta. Now we want to have the cost, so j equals minus y, element-wise, because we want to do it for each training example, log of h minus 1 minus y, element-wise log 1 minus h. Okay, so we have this thing in the brackets, this thing. We want to have the sum, so in MATLAB this is quite easy, we want the sum. And then there's one thing left, so we need to times 1 over m to get the average. So this is our cost. Then we want the gradient, and then the gradient is this function. So we take h minus y for each training example, so that should be h minus y. Now for each training example, or rather for derivative with respect to theta j, we multiply by that specific feature in x. So we need to, one easy thing to do is that we check the size, so check size of h minus y, size of x. Okay, so size of h minus y is 100 by 1. We know that, let's see, h minus y. Yeah, okay, so what we do here is that we want for all features of for theta, so that should be a 3-dimensional vector. So what we can do in this case is that we can take h minus y times x transpose times that, which will give us a 3 by 1 vector. So we call this the grad, and then there's one more thing left, which is that we need to times by 1 over m. Okay, so let's try running this. Now the gradients are what's expected, the cost is what's expected, and same here. So that's how you implement the cost function and the gradient. Thank you for watching.